Well, first of all, a warm welcome from my side and all the best wishes for a happy new year to all of you. I'm very impressed about how many people joined the meeting, and I'm very glad to present the founding pillars of the industrial data space idea to you. And I'm looking forward to the question and answer session afterwards, so that we can go deeper in detail. Well, first of all, I would like to motivate industrial data space. What can it be used for, and what are we talking about? Well, in the core focus of industrial data space, there is data, and as you all know, we are facing a data economy where the data is traded as an economic asset, and data will be the core of new business models, and these new business models can work and can grow if you link data, more data sources, data from different sources, data in completely different shapes, and create a completely new value out of that. And if we're talking about data, we're not talking just about like emails or something like that, but we are talking about data which has a value, and sometimes a very high value in itself. For example, we're talking about something like CAD drawings, financial data, something like material characteristics or sensor data. And on the one hand side, the one data set has a high value in itself if you're looking at a technical drawing. On the other hand side, perhaps the stream of data in the flow of time has the value in itself if we're talking about sensor data. And the industrial data space is the approach to find a mechanism to deal with data as an economic asset. Well, if we're facing towards the data economy, we have to consider one problem or one challenge that companies are faced with. The companies want to link data and build new business models on these linked data in new business ecosystems, and we all know that it's going into that direction. On the other hand side, that's the value of the data, and companies don't want to give it for free, or don't want to know who's doing something with the data and who's using the data. And so we have to find a balance between something like data security and the value of the data on the one hand side, and on the other hand side, the wish of interoperability, data exchange, and creating data-centric services in business ecosystems. And to give a solution to that is the goal and the mission of the Industrial Data Space Association, with the Industrial Data Space approach as a core. So if we have a look at the data economy, I'd like to explain shortly how the data economy works, and how companies can unleash the value of their data. As I mentioned before, we want to combine or link data from completely different sources. We want to link completely different data endpoints with each other, and for example, and especially data endpoints that are not within the same security domain. The data can come, as you see in the picture, from open context data. They can be derived out of the factory from sensors, actors, and so on. They are produced in the value chain in different systems from different players, or the data is stored in all well-known IT systems like clouds, marketplaces, or domain-specific platforms. So if you're talking about the data economy, what are the steps to really unleash the value of the data? The first step is you have to make the data available at all. So if you want to link data in the business ecosystems, you must make sure that you can expose the data to the internet and make it linkable at all. So we have to talk about something like an interface that can be found by everyone else you want to make business with. Then the second step would be to link with ecosystem partners. So we are talking about interoperability and connectivity. So we must talk about how to link two different data endpoints with each other, and not to link only two data endpoints, but a multiple amount of data endpoints, and to create something like an end-to-end network out of that. Well, then, if you have reached to set up this network of linked data, then you want to really exchange the data. And as I told earlier, data is an economic asset, and you want to know the governance, how to control the access to your data, who uses my data, with which purpose, how often can he use it, does he have to pay for it, and so on and so on. So we have to talk about the control over access of data. And then the fourth step towards the data economy is how is starting to create value, because you have succeeded to do the first three steps. So this is the way to really start working and making business in the data economy. That's our view of the world, and industrial data space can be an approach to help companies to work in these business ecosystems. What does the industrial data space approach really provide? Concerning the picture before, we can provide a self-determined control of data flows, and that's what you want to have if you want to act in a data economy and unleash the value of your data. And there are three core value propositions the industrial data space approach delivers. The first is we can really create endless connectivity between all kinds of data endpoints. The second is the industrial data space will provide trust between different security domains. And from my point of view, that's the most important point if we're talking about the Internet of Things and Industry 4.0 and the platform economy. It is always very simple to have to solve the problem of cybersecurity if you're working inside one security domain. But if you want to combine two different security domains, like to different cloud solutions or to companies who are working in completely different systems and ecosystems, then by now there's no real standardized solution for that. And the industrial data space really wants to provide a solution for that. And how that works and what the architectural approach is, Sebastian Steinbuss will present later on. And the third value proposition is industrial data space will provide the governance for the data economy, especially usage control and enforcement for data flows when talking about data as an economic asset, because if you share data and you want to share data, you want to be sure that the governance is all right and everyone follows the same rules, so that you can share or link data without regret. So these are the core value propositions. And if we're talking about industrial data space approach, we have to talk about a lot of technical details. Sebastian will later on come back to that. So I just want to enumerate that and give a short overview. So if you really want to do Industry 4.0 and the data economy, you have to solve several problems and to make things happen. So the first is you have to think about trust. It is the basis of the industrial data space approach, and in doing that you have to deal with something like identity management and user certification. The second is you have to ensure security. Everything in these linked data network or business ecosystem must be secure. So you have to face authentication, authorization, usage policies, trustworthy communication, and so on. Then if we are talking about linking data and creating an ecosystem of data, we have to show how data can be explained, found, and understood. So we have to talk about data source description, brokering, and vocabularies. In order to combine or to link data, there must be a standardized approach to link different data sources or data endpoints. So we have to talk about connectivity, connection of every data endpoint, and again, we have to find a mechanism to bring different vocabularies together, to use different data formats, and to connect each imaginable data endpoints, for example, different clouds or platform solutions. Then, facing the data economy, it's fine to link data, and it's finer to make something with the data. So we have to talk about how to integrate apps into these ecosystems, and there are some technical specialties like remote execution that can be used to process the data which is then linked. And at the end, data markets are needed. Data as an economic asset can be traded on data markets like an asset, and so we have to provide and think about functionalities like clearing and billing, brokering, and we have to face legal aspects and use restrictions. And that is all part of the reference architecture within the industrial data space approach, and Sebastian will have a deeper insight in that later on. Well, I would like to have some more words on the Industrial Data Space Association as the network that is driving, on the one hand side, the architectural and technological development of the industrial data space. On the other hand side, the association brings the industrial data space to life. It takes the reference architecture, the technological core, and makes it and matches it with a reality via use cases in companies, in business ecosystems, in communities, to show how the industrial data space approach works. By now we have a little bit more than 80 companies from more than 15 countries. We have large companies, we have SMEs, we have a lot of research partners and institutions, and they are working together in several use cases. Where are we by now? The Industrial Data Space Association is a relatively young initiative. We've been founded at the beginning of 2016, and we are still on the way. There's a lot of work to do. We have a first draft of everything, and there's a lot of things to play with, like reference implementations and so on. But you have the chance to change and influence the reference architecture, and especially to bring in new requirements that should be used in the next versions of the reference architecture. And as you are especially involved in a large European project, that would be a matter from my side. Please comment on the reference architecture. Please bring in new requirements so that we can jointly make the reference architecture and the industrial data space approach better, and go towards a global adoption of industrial data space as a standard for data sovereignty. Well, where are we by now in the association? We have the first draft of the reference architecture presented on the Hannover Fair in the last year. We are working towards the second version to the Hannover Fair this year. There's an open group creating a DIN specification for the IDS connector as a very core element of the architecture. You can join that process. By now there's a first draft of the DIN spec under review between all the members of the association. We are starting our internationalization. Well, that's one reason why you are all joining the webinar, and we are planning to go live with the ecosystem of the industrial data space, that it can be really used in a commercial context and environment, and we will have that ready in the first half of this year. Well, I come to the end of my part. The core element and a very important part is bringing the industrial data space idea to life in use cases. And we have a lot of use cases by now. You can find them on the internal collaboration tool platform, Jive. By now we have something about 40 use cases with several members of the association participating in each, and they are described, and a lot of them will be shown on the Hannover Fair and on other events, and that would be a task and idea from my side, that you think about setting up use cases with using industrial data space technology out of your projects, and to show how industrial data space works, to validate the technology, to challenge it, and perhaps to bring in new requirements. And that's very important to make it a stable solution, and further on, so that we can go towards a global adoption of industrial data space. That is the introduction on a high level from my side. I hope I could give you a short overview about the idea of industrial data space. Sebastian Steinbuss will now make a deep dive into the architecture and the technology and the approach we have done there. And please have a look at the website, and those of you who have an access to our social collaboration platform, have a look there. The latest documents can be found there. There's a lot of more insights to be found, and it's all worth reading. Well, I'm looking forward to the question and answer session, and now hand over to Sebastian.
Okay. Thank you, Lars, for the great introduction. My name is Sebastian Steinbuss, and I will discuss a little bit more in detail the technical details of the industrial data space. I will describe the industrial data space architecture, bring the architecture into a context for you, and describe briefly the fundamental terms in the industrial data space. What is a connector, a broker, and things like usage control and the information model. Let me start with the context where we see us. Nowadays, especially in Industry 4.0 and other digitized areas, we make use of some real-time area sensor values, actuators, and other devices which are connected via the Internet of Things, via broadband infrastructure like 5G or something like this, to make those data available. Based on this data, we can provide basic data services for information fusing, mapping, aggregation, and things like this. But what we do really want are smart services and product innovations. To achieve this, we need connectivity between all those data sets. And we do not only need those data in automotive or logistics or retail and food or health, we need it in every domain. And what is very important, we need it between those domains, because you will not share data only in your automotive industry, but also to your logistics department and also in retail or other areas. So here is where we see the industrial data space, between the provision of basic data services and the enablement of smart data services. So this is a very small part in this architectural stack, but it is absolutely important to bring all those parties and participants in this ecosystem together to share the data and thereby receiving data sovereignty. We have some attributes that we want to achieve. In our core, we want to enable a secure data exchange. We want a secure data exchange, and this is driven by that we are an open and neutral approach. Everyone can join us and see what we are doing and how we can only establish secure data exchange by trust. So we have certified and trusted participants and components. We are a decentral approach. That means that we do not share all data in a centralized cloud solution or something like this. The data resides always in your warehouse, in your data warehouse, and you can exchange it only if you want to change it. So this means that you keep the sovereignty over your data and your services. This can only be achieved by data governance. So we say what are the rules of the game, and everyone who is part of this ecosystem has to apply to these rules of the game. So what we are a network of platforms and different services, and this is why we can scale with our architecture. This is a basic idea where we started our discussion. So the question here is, how can we achieve this? Especially not being a cloud solution, but a decentralized approach. What we see here is that we do use IDS connectors. The IDS connector is always a gateway to the industrial data space ecosystem. The IDS connector connects to our internal IT systems. May it be the field, may it be databases, or some other systems like ERP systems or something like this. Those connectors connected, and you may use those connectors also internally for your internal structures. The IDS connector is not only a gateway, it can always be enhanced by apps and vocabularies. So we need the vocabularies to have a common understanding about the data that anyone wants to share. And sometimes we do have to manipulate the data, for example. So we have apps to provide some functionality on those connectors. And it is great to have data, but you will have to find those data. And this is why we have our broker. Every connector registers at a broker with its metadata. So the broker knows what data are provided, but does only have the description of the data. He will never know the data itself. And with the IDS broker, one can find the data source fitting for its needs. I will come to the details right now, especially in the first place of the connector. What you see here are two connectors. One is connected to a data source and the other connector is connected to a data sink. If the data consumer is looking for some special kind of data, he will request a broker and query with his needs. The broker will point to another connector, and then both connectors can talk to each other and can exchange data and metadata. Those metadata can be the description of the data, but can also be some kind of policies, what the data consumer is allowed to do with this data. On the other hand, the app store, which here points only to the data provider, it can also point to the data consumer so that we can provide apps. For example, if the data provider only provides data with a REST interface based on HTTP, but the data consumer will need SOAP-based access, one can provide an app that translates between those protocols. This would be an easy example. One can also do data transformation or enhance functionalities like analysis or aggregation. And what is working between those two connectors will always work also between every other connector in the industrial data space ecosystem. So two participants are the minimum in an IDS, but it is open for every other connector, so that the data exchange is possible between every other party. And what is important here, nowadays we tend to do access control, that we provide different interfaces with different data and different privileges to different parties of our ecosystem. But what we can do here is provide the same interface and annotate the interface with policies so that the connector can decide which data is visible to which participant. And you will only have one interface, but with an additional policy. But to the topic of user interface, usage control, I will come back to later on. Here is a little bit more details about the reference architecture of an IDS connector. So we have the execution core container, which copes with a basic functionality for the connectivity between two or more connectors. There are something like message routers or message buses, which can be replaced by other technologies too. But this execution core enables the basic communication between every connector. On the left, we see the custom container. This is the interface to your internal systems. For example, you have a database, you have some IoT devices, or maybe that you have a system like an SAP or another ERP system. You can connect this here. Then the IDS connector will only be a kind of gateway between your internal system and the external access between it. But what you can do too is plug in a custom app in the App Store container. This app may analyze data or transfer data, like I said before. What we also have is a configuration manager. In this configuration manager, one can apply certain rules for the different kind of communication a connector can do. This might be workflow-based or rule-based configuration for the different communication types. This is an example for IDS connector with plugged-in apps. Here, for example, it would be a vocabulary, for example, GS1 XML. So everyone that's connecting to this connector knows that this is a certain data vocabulary, and I can understand it or I cannot understand this vocabulary. There is, like I said, a protocol transformation app inserted, or a data transformation app. Maybe the internal data format is not JS1 XML but something else, and so this app will transform the data for this vocabulary. Sometimes we need things like pseudonymization, especially in health, where we want to provide data from patients, but we do not want to provide the names or the location of the patients. So here can an app simply pseudonymize those data if necessary. Other examples would be data aggregation or analytic, or things like internationalization. To give you a brief example about the data exchange in the industrial data space. The first example is the easiest way, where one connector queries data from another IDS container. So here, of course, it has to be authenticated, and there needs some steps for authorization be done, and the data will be tagged with metadata. And then this query of data will be plugged to any kind of facility or database, and the result set will be calculated and will be delivered to the data consumer. Here, for example, an analytics app can run into the container so that the data itself will not leave the connector. It resides inside the IDS connector, and only the result set leaves the connector. For example, if you are looking in a genomic database for some information, only the result set will leave, for example, that there are 5 patients with a certain kind of disease. All the other data will reside into the connector and are not available to the users at the data consumer. Of course, we can do it the other way around. That the app that does the analytics or the aggregation is provided in the IDS connector of the data provider. This is, for example, very interesting if you're covering big data sets. For example, if you have genomic data, which are really, really large, sometimes it doesn't make sense to transfer all the data from the data provider to the data consumer. Then the query and the app will be provided to the data provider. The app will run inside the IDS connector of the data provider, receives the data, calculates the result, and will only send the result over the internet via an encrypted connection to the data. This is an example for remote data execution, what we also provide within the IDS. But I said also about usage control. Usage control is something more that we what we have nowadays. Today we talk about access control, and we can then control who has access to this data, but we cannot control what the person will do with this data when he has received the data. So here, usage control covers the future usage of the data set. And this is what we can provide more with usage control than access control only can do. We do this with a certain technology stack. The components are shown on the right side that we use here for. Most of you will know those components because it's a standard architecture with a policy administration point where policies can be developed and provided, and the policy management point to manage those policies, to update policies and to see which policies are currently working. We do need decision and enforcement. Therefore, the policy decision point and information point. The policy information point provides additional information for decision making. For example, information about the person or the company that is using the data. And the decision point can decide on the usage of this certain data set. For example, rule-based or process-based. The policy enforcement point intercepts the data flows and enforces the decisions from the policy decision point. So here it can be data can be selected that will not be shown to the consumer. The data will be transferred to the data consumer, but he cannot see it. And there's also a policy execution point that can execute actions in the system. For example, it can delete data after, I don't know, 2 days, for example. The policy execution point may, for example, filter information. If you say, okay, I will transfer all my data, all my sensor data to every consumer, but not every consumer will have access to all sensor data. If you're a certain type of users, then you will only have access to a lower resolution, for example, an aggregation of the last 30 seconds. And the policy execution point will have access to all data sets, but we'll give it back to you with a lower resolution, like I said, with the 30 seconds delay. What we can do here is we can do a lot of technical enforcement, of course, but we cannot do everything with technical enforcement. Latest, when data leaves the connector, we are not able to enforce every policy that we would be able, but the technical effort would be sometimes too high. So herefore, we do have organizational rules and legal contracts like we have today, and the technical enforcement is just a kind of help to apply to the rules that are given by the policy. Here an example for data usage controls, here with an OEM like a car manufacturer and a supplier. What we do see here is that data, especially the inventory range, will be provided via the IDS to the OEM with the obligation to delete those data after 14 days for some kind of reasons. In the first place, because they are too old then. But what we do see here too is that they are covered, they point to a contact person, because this data is highly relevant for logistics and for the planning of the production. But on the other hand, the procurement may not see this data because it would have a high strategic value for this one. So, and in return, also inventory range and part demand are transferred to the tier 1 supplier, also with the obligation to delete this data after 3 days, for example, and they are bound to a certain target system so that they cannot proliferate in the whole all systems of the company. We do not have one technology in place for usage control. We are mainly talking at the moment about the induced framework that we use for usage control, but there are also 2 other approaches that we are using. One is a label-based usage control, UCON, and information flow tracking and provenance tracking. 3 of them are provided by the different Fraunhofer institutes, and those 3 technologies can be used for usage control. And there are also other technologies that can be used to apply usage control to data. What I said before is that every IDS connector can talk to each other IDS connector, and this is the identification process, or I would like to call it the IDS handshake. What we do have as prerequisites is that every participant and every connector has to be certified. There are different ways to get certified as a participant and as a connector. I will come back to this later on. But what you need is the certification, and you will receive an X509 certificate that you have to place inside your connector. Because this is the thing you need first to establish a secure connection, a TLS encrypted connection between 2 participants. So in the first place, every connection inside the industrial data space is secure because only participants of the IDS with a valid X509 certificate can establish a connection to any other connector. When you have established a secure connection, every connector gives his own self-assessment based on the IDS info model. This says, I'm this participant. You will receive information about who am I as a company, which legal form do I have, what is my name, where do I reside, and things like this. You will also get information about the connector, what kind of connectors I provide, and which kind of trust level my connector has, and which abilities my connector has. And you will get information about my data endpoints, because I can have various data endpoints there, and about the data I do provide. If I would like to, I can check this information against the IDS identity provider, because I can assume that that the other connector will lie to me, and then I can check this information against the IDS identity provider and see if this partner is trustworthy or not. I can evaluate the information that was presented to me to see if this partner is trustworthy, if the certification level of his connector and of himself as a participant is enough for the communication. And in the next step, I will check if the data that is provided is consumable for me. Maybe I cannot understand it because he is working in a totally different domain. While I'm in logistics, he will provide health data, and I will never have the need to understand this. On the other hand, maybe he will provide some EDI data, but I do need OHS data. This might be understandable, but I need some certain apps to transform the data, for example. Or I can really understand this data, and this data have a value for me. And then I can finally exchange those data. This is the IDS handshake, and this is what has to work between every connector into the IDS ecosystem. I said about the IDS information model, this is absolutely crucial for the IDS to work, because we do not provide an API. This is a question that arises often from developers. So please show me your API, and I will show me if you are good for me or not. But we do not provide an API, but we do provide an API for your API. So we have the IDS information model that, as I said, describes data endpoints, connectors, and participants. And we do have it in a very abstract way, the conceptual representation in the IDS reference architecture. We do have a declarative representation as RDFOWL as the IDS ontology, and we do have tooling support, programmatic representation for this, based in Java and Python at the moment. This is what is usable right now. As I said, this is the structure of the high-level structure of the IDS information model. We do know information about the participants. We do know about the infrastructure, about components, about runtimes, about the applications that are available, the services that are available, and the data that are available. Here, very interesting, of course, is the structure of the data and seeing data as products, because this is what Lars Nagel mentioned at the beginning. The data are an economic asset today. So we have to define what are data products to trade data, the legal and economic overlay for commodities. We do describe the data endpoint for the retrieval of the data. This means the interaction interfaces of concrete protocol bindings. We provide an interaction with the data interface, the interactive interface for querying, listing, retrieval, and things like this. And we do describe the content, the data asset itself, with its structure, its context, classification, provenance, and things like this. This is what you need to see if this data are interesting for you, or if it's not interesting for you. Does the data have the right quality that you need, or does it have not the right quality that you need for your system? Every data endpoint here provides certain protocol bindings and operations. And here you can simply plug in your own APIs. May it be a REST API, may it be MQTT, may it be a SOAP. Everything that you would like can be described here in a generic way and in an understandable way for every other connector, so that you can not simply but easily provide a certain interface, a programmatic interface, to exchange data with a system that is described in this way. So here is your API. Here is where you can describe your API in a generic way so that everyone understands and sees if he can consume data from you or he cannot consume data from you. The last thing I would like to talk about are our security profiles. We have seen that we do have different use cases with different requirements to IDS connectors. And we cannot bring everything into one connector and every requirement into one kind of connector. So we have to differ into profiles. What we've done so far is we've took a look at certain use cases, at highly relevant use cases that we are faced with. For example, industrial use cases from Industry 4.0, or retail use cases and logistics use cases, research use cases, internal and external use cases, and things like this. And we identified that there are 4 dimensions where the connectors differ from each other. Those connector types differ from each other. This is the kind of development, the roles that are supported, the communication abilities, and something we've summed under higher security classes. What we've got here are our 4 security profiles with some important insights. We do have those 4 profiles. They're named at the moment Base Free, Base, Trust, and Trust Plus. Those names we use currently, but they are not very well chosen, so we are thinking about giving them the right names. I will come to the details of this on the next slide, I think. What we find as very important insight, all connector types can communicate into the public IDS system. This is what I said before, but we've written down a tier set. It's absolutely necessary that every connector can talk to each other connector, but not the base-free connector. The base-free connector is an open source implementation, for example, for research projects, or especially for internal users that cannot join the public IDS, but you can use the IDS technology, the IDS approaches in your own ecosystem, in your own security domain. And so the base-free implementation will be public available. As you see here, I have a matrix with those security profiles and those dimensions we have. The base-free connector will be available as open source. Not today, but soon it will be available as completely as open source. The base and the trust implementation will be available only to the IDS community. So you have to be an IDS member to work on the source code of those connectors. And the Trust Plus, or the managed trust, is bound to stronger SLAs. What we do need here are certain SLAs that some kind of security issues will be fixed in a certain time. So here we do have stronger SLAs. What I said before is that we talk about classes here. We have reference implementations for each security profile class, but of course everyone can set up his own connector and develop his own connector for each class. As I said before, every connector has to support all roles, especially the trust and the managed trust or Trust Plus has to support all roles into the IDS ecosystem. The base connector should also support all roles in the IDS ecosystem, but maybe it is not trustworthy enough to support the billing and clearing of data. So this is optional, that when you provide data via the base connector, that you support billing for the data. But what you do achieve is the sharing of data. The base-free connector always needs completely own infrastructure, beginning from the identity provider and the certificate structure, data brokerage, and clearing and billing is completely set on your own. In communication abilities, all connectors can talk to each other. They are fully interoperable, not the base-free connector, which is only for the private IDS with self-signed certificates, but the other 3 profiles are fully interoperable, but one has to know that the base connector has some kind of reduced trust, and the trusted connector is fully interoperable with a free decision to communicate. He can decide if someone with a base connector offers data, if he wants to accept those data, or he says, no, this data is not trustworthy enough. On the other hand, if the trusted connector is requested for data from a base connector, he can decide if this connector is trustworthy enough to provide those data, or if he will get only a subset of the data or his trustworthiness. The managed trust connector here is the same as the trusted connector, but he will always have to have a hardware anchor so that one can check if the system itself was touched or changed by anyone that maybe was not allowed to. Of course, the trusted and the base connector can implement everything the trusted plus connector implements. They don't have to. In the higher security levels, there are a lot of details that are described here. where the main point here that differs the base connector to the trusted connector is the topic of usage control. Of course, the base connector should set policies for usage control and should enforce the usage control. But this is based on trust. The trusted connector has certain techniques implemented, like remote attestation, that the connecting connector can see if this connector is really trustworthy and will enforce the policies I've put onto my data. So this was a brief overview about the IDS architecture. I told you about the core components and what the core components are doing. What I presented to you is partly work in progress. We're bringing for you the next reference architecture in April 2018. There are a lot of new things that we don't have in the reference architecture that we had since April 2017. So some things might slightly change, but this is the direction where we are currently working on. You will find a lot of more information on our Jive platform, and especially on the next reference architecture in April. So we are looking forward to the Hannover Fair, when we can present everything that is new in the new reference architecture. So I would like to say thank you for listening, and I think now it's time for a question and answer.